I'm going to walk you through the Chapter R notes for Algebra 2, MAT 111. We're on Chapter R.3, Exponents, Roots, and Order of Operations. The first thing you need to recognize is that we use exponents to really show repeated multiplication. So repeated meaning the same number. So if I've got 2 times 2 times 2 times 2 times 2, we can write that as, actually this is 5 factors of 2. 2 is the base and 5 is the exponent. Base is the factors, what is actually being multiplied, and 5 is how many times it's repeated. So it's like I've got 5 2's, not 5 times 2. 2 times 2 times 2 times 2 times 2. So 5 is called the exponent, or sometimes it's called the power. It's repeated multiplication. So you could always see an exponential expression like this and turn it back into multiplication, repeated multiplication. So it's important for you to understand. Now, you know, we have 2 to the 5th. Well, this is 2 numbers. If that's equivalent to 2 times 2 times 2 times 2 times 2, that's the same as 4 times 2 times 2 times 2, 8 times 2 times 2, 16 times 2, 32. I just underlined what I was doing, and I was just going from left to right with repeated multiplication. You can actually group them. So it's 4 times 4 times 2, which is 16 times 2, and you get to the 32. We'll go over order of operations very soon. Okay, well, I mentioned that this was called an exponential expression. I'm just going to write it down. It's a expression with exponents, and they're also called powers. So, you know, since we're doing repeated multiplication, we come back into the even and odd rule. So, for instance, negative 2 to the 4th equals, or negative 2 to the 5th equals. What this is saying is negative 2 4 times. This time I'm putting it in parentheses because I'm using the negative signs. So negative 2 times negative 2, we'll do this one first, is positive 4. This negative 2 times negative, notice how I'm not overlapping, and I'm multiplying between these two, is also positive 4. So when I multiply those together, I get positive 16. But, so this one had a power of 5, this one has a power of 5. This was a positive 2 5 times. This is a negative 2 5 times. So I've already kind of established that, whoops, I need one more. 2. So 1, 2, 3, 4, 5 factors. I've already established that 4 of these is equivalent to 16. But I still need to multiply by negative 2. 16 times negative 2 is a negative 32. So the answer here is negative. So if you notice, I had 5 negative signs. I was multiplying 5 negative numbers, which is odd. The answer became negative. 4 negative numbers, even number of them, the answer is positive. So I showed you that before. What is this? Oh, let me do this one. Negative 2 to the 4th. What is this saying? How does this differ from this? Well, this is saying that I've got a negative. How many negative signs do I have? Is that also being raised to the fourth power? No. Only the 2 is being raised to the fourth power. If I want to raise the negative 2 to the fourth power, you need to put it in parentheses. You need to be very careful when you want to do this, but you put this in the calculator. So this is negative 2 times 2 times 2 times 2. Or remember what I mentioned, a negative sign, a negative, is equivalent to multiplying by -1. So this is negative 16. I'm going to show you what I mean. So let's do negative 2 raised to the fourth power. The calculator tells you it's negative 16. Now recognize that if you wanted negative 2 to the fourth power, or the quantity negative 2 to the fourth power, now you have 4 negative signs, and that's positive 16. So be careful what you put in on your calculator. The next item that we can use is kind of, they're also powers. They just look a little bit different. Roots. Talked about exponents. Roots are related. Roots are the inverses of exponents. So roots are the inverses of exponents. What that means is a square root undoes, I don't know if that's really a word, a square. So for instance, if you say that x squared equals 36, and I'm sure you've seen this, we take the square root of both sides and we see that x equals 6. So when I see the equation, the expression, the square root of 121, what equals what? That is equivalent to, actually, I'm going to put this one with an arrow also. That's equivalent to what? The question mark, squared, equals 121. Because if I square both sides, what squared equals 121, because a square root undoes a square, but also a square undoes a square root. Oh, by the way, the answer for this one is that question mark. What squared equals 121? It's a lot easier to see it that way. That's actually 11. I didn't give it a variable. I just utilized the question. So I could say what? The square root of 121 equals what? It's the same as what squared equals 121. And then we get, of course, it's 11. 11 times 11 is 121. You need to know those multiplication facts. So, you know, we got to mention a little bit about negative. So if I have negative 5 squared, well, that's negative 5 times negative 5, that's positive 25. So squares are always positive. If I say the square root of 25, I'm not going to be coming up with 5. I'm sorry, I'm not going to be coming up with negative 5. We just say 5. So this is a positive root. If I wanted to come back with negative, I'd have to say negative square root of 25 is negative 5. That's the negative root. So these are always positive. And for now, this number underneath, it needs to also be positive, because you have to ask yourself, what squared equals a negative number? Let's see, what squared equals, let's just say negative 25. How do I get negative 25? What squared equals negative 25? Well, if this is positive and I square it, I'll get a positive answer. If what's in here is negative and I square it, I will still get a positive answer. So for now, we're going to say this is not a real number. And just going back here, this is also called the principal square root. We'll see later that so let me, have you seen this? This is a cube root. And what does that undo? It undoes cubes, which are just powers of 3. You know, we use squares for 2 and cubes for 3. That actually comes from geometry. A square, square units, and a cube, a cubic unit. So powers of 3. So instead of seeing this, cube root of 27 equals what? We can turn this into what cubed equals 27. And after a few moments, you might see that what is going to be 3, because 3 times 3 times 3, 9 times 3 is 27. Also, can we do this? Negative 27. What cubed equals negative 27? Well, I want to say negative 3, but let's check it. Negative 3 times negative 3 times negative 3 is 9 times negative 3, which is negative 27. That's good. That works. So it's okay to have negative numbers under an odd root. It's okay to have negative numbers under an odd root, because then the answer is going to be negative, because an odd number of negative signs will get you a negative answer. Which brings us to the order of operations. Please don't call it PEMDAS. Please. Order of operations. So, first off, there's only 2 operations: addition and multiplication. And we saw that multiplication was repeated addition. We saw that powers are repeated multiplication. So really it comes just down to addition. And addition's weak, and we can make it strong by repeating it. The first thing we're going to do is, now this is on page 27 in your textbook. I'm going to break it down into 4 steps. They actually use 5. The first step is work inside grouping symbols. Inside grouping symbols. What is a grouping symbol? Fraction bar is its own grouping symbol. So you work the numerator, when you have one large fraction bar, and then the denominator. And then you do division. So for this one, division is last. You know about parentheses. You know about parentheses. You know about brackets. And you know about braces. We use these three to work with nesting, so you know what goes with what. Work inside grouping symbols. So you'd start with the outer brackets and then work your way in. So this is going to be the first set. After you do that, this is going to be the second set. And then you finally do the third set of brackets, or parentheses, or braces. The other item that you need to worry about is absolute values. So this is really kind of a function. You need to get rid of those first off the bat, so you're just dealing with numbers. That's a lot of information. Second in the order of operations is evaluate or expand. All powers. And roots. You're not going to expand roots, you're going to evaluate roots, but you can expand powers, because powers are just repeated multiplication. And if you notice, our next step is going to be multiply. Well, multiply and divide. As they occur. From left to right. And our last step, add and subtract. Remember, this is the same operation. In order to divide, you multiply by the reciprocal. In order to subtract, you add the opposite. So they are the same operation. They are on the same level. You don't do the multiplication first, then the division. So add, it's going to say the same as the other one, just add and subtract as they occur from left to right. You know, I am out of room, but why did I say don't use PEMDAS? See this whole big thing? This is a lot more than a P for parentheses. A lot more. E. Usually we just say E. E stands for exponents. Oh, we do exponents next. But don't forget roots, because roots and powers are related. They're on the same order. They undo each other. Multiplication and division. This is M and D. Or you could even say D and M. I don't care. It doesn't matter. It's as they occur from left to right, not only the M's, then the D's. Multiplication, then division. And the last step, AS, but it could also be written SA. So please don't think of it as PEMDAS. This is so much more than just a P. So let's try some examples of order of operations. Let's try 4 minus 12 divided by 4 times 2. Don't worry, you know how to handle fractions. So, no grouping symbols, no exponents. We go for multiplication and division. We've got 1, 2, 3, 4 numbers, 1, 2, 3 operations. Subtraction is first, division is next, multiplication is last. Subtraction is on level 4, these two are on level 3. So the first one we do is the division. So I'm underlining it. I'm underlining it and working right below. Instead of subtracting 12 divided by 4, I'm going to subtract 3. See how it turned into a 3? And then I'm still going to multiply by 2 because I haven't done that yet. Our next item is multiplication. So 4 minus 3 times 2 is 6. And then finally 4 minus 6, push pull, negative 2. Negative 2 is the answer for that one. That's how you work order of operations. I prefer fraction notation. This, I'm going to say it, I'm going to write it. That division number is evil. It's so confusing. It kind of looks like a subtraction, looks like a addition, but it's not the same. So what's going on here? I can rewrite this as 4 minus 12. Well, I'm dividing by 4, and then what's happening? Then I'm multiplying this whole thing by 2. But it can also be written as, since I know how to multiply fractions, 12 times 2 over 4. So you see how now this is all grouped, the multiplication and division? It makes it a lot easier. I could even see that 2 goes into 4 twice. And 12 divided by 2 is 6. And I'm back up at 6. Yeah, we'll do another example. I'm trying to see some good ones here. I want one with a fraction bar. I'm just trying to pull them out of the homework. Let's try this one. This is actually number 80 in your textbook. Negative 9 plus square root of 16. Negative 3 squared. All divided by negative 4 minus 1. So, number 1, fraction. Work with the numerator, work with the denominator. Once we do that, once we work with them separate, well, negative 4 minus 1 is kind of easy. That's negative 5. And the top, I've got 2 sets of parentheses. This, I have something to do. So let's take a look at this first set. Within this set, I've got a square root. I can evaluate square root. It's a 4. So I'm going to change that to negative 9 plus 4. Okay? I've got to finish that. But at the same time, I could work on this parentheses because they don't overlap. You got to worry about when they overlap. These are not overlapping. Negative 3 squared. What's squared? Is it the negative 3 or is it just the 3? Hope you're recognizing that it's just the 3. So the opposite of 3 squared is negative 9. Don't go distributing here. If you can do what's inside a set of parentheses, do it. It makes things a lot easier. That's a negative 5. I'm going to keep this negative 9, and my denominator is negative 5. Now, I hope you can recognize that this negative 5 and this negative 5 cancel, and you get negative 9. And that's the answer. Also look, negative, negative, negative. I'm just multiplying and dividing, correct? So now I could kind of cross this off because I'm on the same level. I can do multiplication and division as long as I know what I'm dividing by and what I'm multiplying by. You can I don't have to finish the numerator. That's what I'm getting at. And that's where canceling comes in. I've got 3 negative signs. My answer should be negative. Yep. Yep. Or you could do it the long way. Negative 5 times negative 9 is a positive 45 divided by a negative 5. A positive divided by a negative is a negative. 45 divided by 5 is 9. So I showed you also you can cancel those two factors, negative 5 over negative 5, and have a negative 9 left. And I just saw the answer, so that's right. And that's it for 4.3. The best thing for 4.3 is to practice. You are going to be asked to evaluate expressions. So let's just take a look at that. Let A equal negative 3, B equals 64, and C equals 6. Stay away from your calculator. Stay away from your calculator. Evaluate. Square root of B minus 4A over C squared. So what do we do? Well, I call this plug and chug. I'm going to write it down. You plug in. B is 64, so that's going to go in that position. A is negative 3, it's going to go in this position. I hope you recognize what's going on between 4 and A. It's actually squared. I'm sorry, they're multiplied. 4 and A are multiplied. And then C squared, the entire value of C squared. So just quick, A squared is going to be negative 3 squared, which is 9. So that's just an aside. Here it's a positive, so I just wanted to point that out. So I just replaced square root of 64 minus 4, and since it's a number, I'm going to put it in parentheses, and 6 squared. Work the numerator, work the denominator. We end up with 8 minus a negative 12 over 6 squared is 36. So I'm going to go over here. I'm going to change this to 8 plus 12 over 36. Instead of subtracting a negative 12, I'm going to make it a positive 12. This is 20 over 36, and it can be reduced at least by 2. And I get 10 over 18. I recognize that. 10 over 18 divided by 2 divided by 2. I saw another 2 in there. That's a 5. That's a 9. 5 nines. 5 nines. And I just saw my answer, and that's right also. So yeah, I didn't see a 4 right away. So I did a 2. I just had to do it again. So I could have done divided by 4 and got 5 ninths, but I broke it down. Don't waste time looking for something bigger to try to get done faster. If you chip away at it, you got smaller numbers and it's easier to see. And that's it for, what do we do? R.3.